All right, well, it's just ticking over to 11 o'clock, so let me go ahead and get going again. Good to see you all. I hope you all had a nice spring, whatever it was, refresh, replenishment. That was funky, having not the whole week, but I hope you had some time to take some time yourselves before we get started again. It feels like we should have like about another week left of school, but apparently we don't on the calendar. So we've got some work ahead, and we now move on to the next set of slides, which deals with air pollution. And as I've made this comment before, everybody, these topics are also, obviously closely intertwined. They're linked. The emissions that we see from energy, much of what we read about in terms of the decarbonization of our energy portfolio is driven by air quality issues, right? And the fact that we have, real significant issues moving forward. So let me start with this slide here. So this is one of those slides that you are likely to see on exam number 2. And the reason you're likely to see it is it's one of those slides that will, I hope, stimulate some discussion here early on. So what are we looking at? So we are looking at, as of the end of February, counties in the United States that have poor air quality. What I mean by poor, that is officially designated as non-attainment. In other words, the air quality in those counties does not meet standards as set out by the EPA, right? And the second one is, what do these colors mean? Well, there are 6 different colors here. And each one of those colors represents the combination of either 1, 2, 3, 4, 5, or 6 of the most important pollutants, right? The acronym that you see down there, NAAQS, and it's in the book, stands for National Ambient Air Quality Standards, right? The National Ambient, meaning background, air quality standards. So the EPA sets these limits, these levels for these pollutants, and we're going to talk about what these pollutants are in just a second. So green means that county has air quality that fails based on 1 pollutant, whereas anything that is pink has air quality that fails based on all 6 of the so-called key or criteria pollutants. So the question in the exam would be, what's going on here? Discuss. What do you see? What jumps out?
California.
Okay, Gavin, you popped up. Yeah, California, tricky. Okay, are you from California, Gavin?
No, I'm here in Texas.
Right, so I know there's a Californian out there, and I know there's someone from the Central Valley or LA. So who's from there and who wants to talk about what's going on in California?
I'm from San Diego, California, and I know that certain areas like in Santa Barbara area is like really, really badly polluted. That's why the weird thing is the worse the pollution is, the better the sunset is. So in LA, there's a lot of factories and manufacturing. And then in the Southern California, there's a nuclear plant. So there's just a lot of people, a lot of cars, a lot of just pollutant in general.
Okay, and I'm seeing some things come up in the chat. So I see major cities, wildfires, highly populated areas have worse air quality. So people, population, industry, right? Cars. Wildfires, so that's an interesting comment. Wildfires aren't built into this, Catherine. They do impact air quality enormously, but this is excluding. This is just the 6 criteria pollutants, but you can't discount wildfires, right? Really, Central California, use of pesticides and smog in the valleys. Sarah, talk to me. Nicely noted there. What's going on in the Central Valleys?
There are a lot of farms there that use pesticides that are really bad for the environment. I know a lot of almond farms use some that really aren't qualified to meet standards. So. Okay.
Yeah, so there's pesticides, there's fertilizers, and we're going to look at later on in this course, we're going to look at nitrogen as an important fertilizer, and the nitrogen that's not taken up by the vegetation and any crop that you're growing gets into the atmosphere. and becomes part of the pollution. So there's people, there's cars, there's factories, there's agriculture. So if it's people and industry and cars, oh, there's a sound, it sounded a little distant. Who's that? Oh, is someone chatting or is that back? I can't make that out. Was someone just not muted?
Someone's just not muted.
Okay. Let me see if I can figure out how to. Sorry about this. I need to get that mute on. If everybody can hear me, if you wouldn't mind just muting, that would be really helpful. All right. There's some way I can mute everybody. Surely. There we go. Okay, we're back, I think. So what's going on in Florida? Why does Miami or Tampa, where I was just for spring break, why don't they have air quality issues? Do you think? I know there's people there, there's cars there, industry there, agriculture there. Doesn't that surprise you? Huh. Anybody want to have a stab?
I mean, I live in Tampa. I'm actually in Tampa right now.
There you go, Nolan.
So, you know, I'm obviously don't live in California, but I know just from an outsider's perspective, at least, it seems like everyone in our area definitely cares a little bit more and like really tries to limit. Well, first off, there just really isn't any factories in downtown Tampa.
Okay.
In Ybor, which is North Tampa, there's a couple cigar factories and a couple of local breweries. But the agricultural stuff goes on north of Tampa.
Mhm.
And in Tampa, like I said, there just really isn't that many factories. Whereas if you look in LA, there's a lot of foot traffic, a lot of people. But you know, again, from an outsider's perspective, I could be totally wrong, but it appears that there is more factories, there's more production and stuff like that going on in that area. Whereas Tampa is more of there's jobs and there's stuff like that, but there's not that many factories.
Okay, so that's part of it. And then also the geography. Think about Miami, more renewable resources coming up in the chat. That's possible, but think about Miami. If you had a series of big coal-fired power plants on the eastern seaboard, Miami, Fort Lauderdale, and they were putting pollution into the atmosphere, where would that pollution go?
They're going to the sea.
Yeah, yep. Right? So the air patterns and the wind move from west to east across the United States. So if you've got pollution in a place like Florida, that gets dispersed pretty quickly. Okay? It's warm, it's humid, there's turbulence, no place gets, and Nolan, you can back me up on this, no place gets more thunderstorms than Florida. And that pollutant gets dispersed pretty quickly, right?
Lightning capital of the world.
Say again?
Tampa specifically is the lightning capital of the world, so we get a lot of storms.
So you get a lot of storms because of the fact that Florida sits out in the Gulf and land heats up much more quickly. There's some other meteorological things going on. So it's not just where people are or cars or factories, it's the geography of the region that also plays out. And I'm going to move on because I'm going to come back to California and make that point a little more specific. But before I do, just look at the DFW Metroplex, right? There's 9 counties here that fail air quality based on 2 standards. And we'll come back and explore why that is the case, right? So yeah, there are metro areas. You look at Chicago, you look at metropolitan Atlanta. That's important, but there are other metro areas, large metro areas that don't have air quality issues, right? Like Seattle, for example. So it's where you are relative to the pollutants that are being created. Right, next point here. There is a really key distinction here, everybody, between what we call primary pollutants, okay, and secondary pollutants. So that's the first point that I'd like you to appreciate. So primary pollutants are those substances that are emitted directly into the atmosphere, right, from the source. Now, those sources can be mobile, right? They can be vehicles, they can be natural, although that's a much smaller contribution. There can be stationary sources like coal-fired power plants and other factories, but these are pollutants that are emitted directly from the source. So things like nitrogen dioxide, sulfur dioxide, PM. PM stands for particulate matter, fine suspended particles in the air, and CO, carbon monoxide. So for example, the incomplete combustion from your car comes out of the tailpipe as carbon monoxide, right? Those are primary pollutants, okay? Secondary pollutants over here are pollutants that are transformed, or secondary pollutants involve the transformation of the primary pollutants into secondary pollutants. And that transformation occurs largely through the interaction with sunlight and carbon and water in the atmosphere. So for example, let's say we're putting out nitrogen dioxide here, right, coming out of a cement factory or a coal-fired power plant. That nitrogen dioxide here is split up by sunlight into NO and an O, an oxygen atom. And that O, that now loose free O, joins up with O2 to produce O3, which is ozone, right? A pollutant, a secondary pollutant. Here we've got H2SO4, sulfuric acid, or HNO3, nitric acid. Those result from the breakdown of the primary pollutants, sulfur dioxide and nitrogen dioxide as well. So is that clear with everybody? I want everybody to make sure that you're happy with the difference between a primary and a secondary pollutant, right? Is NO a pollutant? It is, right? It is a pollutant. Nitrogen oxide, yeah. Okay. All right, everyone. These are the big six, right? So the map there of the counties that are failing air quality based on 1 through 6, these are the 6 pollutants. I need you to just remember what these are. So CO is carbon monoxide, right? I don't want you to know exactly where it comes from or anything like that. So CO is carbon monoxide, PB is lead, NO2 is nitrogen dioxide, O3 is ozone, PM is particulate matter, and SO2 is sulfur dioxide. So carbon monoxide, PB is lead, NO2 nitrogen dioxide, O3 ozone, PM particulate matter, SO2 sulfur dioxide, right? They come from a variety of sources. One of those is a secondary pollutant, and that's ozone. All the other 5 are primary, right? So yes, then your question of will NO be a secondary pollutant? Yes, it will, because it's formed by the breakdown of sunlight from nitrogen oxides. Okay, so those are the 6 pollutants. Now, I don't expect you at all to remember this table. I'm not a big fan of putting tables on slides. This is from the book, table 4.1. But I've put this up for a specific reason, right? I want to refer to a couple of things. The EPA comes up with a series of standards. And here there are primary standards, right? There are also a set of secondary standards. I don't want you to worry about secondary standards. Primary standards are the ones that impact human health, right? These are the standards that directly impact the health of you and me. Secondary standards are standards that are harmful to the environment, ecosystems, other organisms, right? So let's just focus on primary standards for a moment. There's 2 things I want you to take away from this table, right? One is that when you look at the different standards here, and just the annotation tool out, right? Some of them, like carbon monoxide, right, is a standard over an 8-hour period, okay? Others are an average over 3 months. Some of them are an annual average. In other words, if you are the owner of a cement factory and you're putting out nitrogen dioxide, as long as you are not exceeding 0.053 parts per million as an average in the year, you're okay, right? If you exceed that, you're not okay, right? So that's the first thing I want to point out. The second thing I wanted to point out, I'm going to point out 3 things actually. The second one is this PM. Here you see PM, and then it's got a little 2.5 here. Does anybody know what that is? PM 2.5. There are 2 different criteria for particulate matter. There's 2.5 and there's 10, PM 2.5 and PM 10. Anybody know what that is? What that refers to? It refers to the size, the diameter of the particulates, right? So 2.5 is 2.5 microns, micrometers, right? And if you don't know what a micron is, there are 1,000 microns in a millimeter, right? And a human hair, not that I have a whole lot of this stuff left, but a human hair is about 75 microns. So something that is 2.5, you can't see with the human eye. Very, very, very small suspended material, right? Does that make sense? So that's the second thing I wanted to point out. And the third one that I wanted to point out was this one. And I'm going to circle this a couple of times. This is ozone. Ozone, and this is when a book goes to press, it becomes out of date pretty quickly. There is a new standard here. This standard for ozone is 0.07, right? So I do want you to remember that number for future reference. And the ozone standard is an 8-hour standard. And the reason why I'm singling out ozone, everybody, is because ozone is the one pollutant that we still struggle with enormously here in the US, right? Around the world, air quality is compromised by a bunch of pollutants. I would say, and I'll show you some information on this, fine suspended particles in smoke and dust and soot and so on is the major problem on a global worldwide basis. But in many industrialized countries like the US, ozone remains the key pollutant. And I'll explain how it works and all of that, right? So any questions there? Does that make sense? Don't go and remember these standards. Just remember that ozone is 0.07 parts per million over an 8-hour period. In other words, if you needed to go and determine whether the air quality, let's say I said to Nolan, all right, we're interested in the ozone levels in Tampa right now, you would need to go outside between 9 in the morning and 5 in the afternoon and continually measure ozone and see if it exceeded 0.07 parts per million at any particular time, right? That's how that standard is determined. So I hope that makes sense to everybody.
How do you measure the ozone?
How do they measure the ozone?
Yeah, like, are they taking like samples of the air after every 30 minutes or something?
Yeah, no, so great question, right? How do they measure it? There's a little instrument, inexpensive instrument. You know, there's various ways to do it, but it all comes down to a pretty high-tech, simple instrument. It's like an air quality monitor, and you just hold it out at a certain height, and you measure it over a 15-minute period, Janira, and then you look at that average, and then you look at it for 15 minutes. And so it's basically every 15 minutes over an 8-hour period. Does that make sense?
Yeah, that does. Thank you.
Okay, cool. Good question. Right. Okay. So there was a question on the chat. Do we need to remember all the numbers? No, you don't need to remember those numbers from that table. All right. Now, instead of going through each and every pollutant in excruciating detail, what I've decided to do here is just look at the trends. So what have the air quality trends been? What have the pollutants done in the US? I should emphasize that this is for the US. And what I've done on this diagram, everybody, here across the middle, the horizontal dashed line here represents the most recent national standard. And I've taken the average for these pollutants for the US. So this is the average of every monitor across the United States, okay? And I've plotted them whether the values were above the national standard or below the national standard. In other words, if I just take this data point over here, sulfur dioxide in 1990 was about 52% above the national standard on average for the United States, right? Each one of those data points represents many, many millions of readings summarizing the pollutants. Okay. Incidentally, lead is not on here, right? Because lead concentrations now are so low because of unleaded gasoline that they don't plot up on this. So what do you notice? Someone talk to me about these trends. What can you say about air quality in the United States from 1990 to 2008? What are the take homes from this?
It looks like it's gotten better because there's a decline in the trend.
Good, Holly. Would you say somewhat better or a whole lot better?
I would say a whole lot better, except for ozone stays pretty average above the standard.
Right. Yeah. So neat observation, right? Things have gotten a heck of a lot better. I know often people like to maybe not brag about how bad their air quality is, right? But when you canvass people, like, what do you think of the air quality in Fort Worth? Some people say, oh, that's pretty poor. Or, okay, if you're from Oxnard, California, you go, okay, the air quality is really compromised here. But the bottom line to this diagram, right, when you look at all of these trends, and I'll just put this in green, these trends are all going here. I mean, look at sulfur dioxide. Over a 30-year period, sulfur dioxide has gone from being 50% above the national standards to 80% below. That's an extraordinary environmental success. You know how environmentalists often want to be doomy and gloomy and we're all going pear-shaped and everything's going to, you know, air quality has improved dramatically in the United States, right? And as Holly said, with the exception of this, my computer wants to restart at 11:36. Are you kidding me? No, I don't want to restart. That's obnoxious. Why does Microsoft do that? I've just got a notice here. Thank you, Mr. Gates. I don't think so. So if this computer crashes, this lecture will have to end a little early, which is enormously frustrating, but let's keep going. So ozone here, Holly, you're right. When you look at 2012 onwards, ozone is the pollutant that we struggle with the most, right? Bar none. Okay, so air quality has improved. Here's an example, right? This is nitrogen oxides in 2005 and nitrogen oxides in 2011. And I've just gone from low to high here to make the point that air quality is improving. You can see less red, better air quality, okay? But the challenge is this, right? The challenge is that even though those trends look really, really good, okay, we still have almost 125 million people in the US living in counties with compromised air quality, right? This is just the 8-hour ozone standard. And you can see of the 137 million, the number of people in the US, right? So, you know, not quite a third, but a large chunk of people in the US live in air that is compromised, okay? And that is almost exclusively due to ozone. Yeah, we've got some suspended fine particles and some suspended coarser particles, but lead, nitrogen, carbon monoxide, SO2, we've done a remarkable job, right? Ozone remains the biggest challenge, for sure. So what is ozone? How does this work? Why are we struggling with ozone so bad? So this is a map very similar to the first one. This is, I've updated this from, I haven't updated it to this year. This is March of 2020, just prior to the shutdown from the pandemic. This shows counties that have either extreme, severe, or serious, all the way through to marginal ozone issues, right? These are the counties that struggle with ozone. So very similar to the first map, right? Nolan's in great shape in Tampa. No real issues there with ozone. The 9 counties here in the Metroplex and the 12 counties down in the greater Houston-Brazoria area all struggle with ozone, right? California even more. So let's talk about ozone just for a little bit here. Gosh, I'm really frustrated that this computer may reboot. If it does reboot, let's see. I tell you what, let's do this. Let me keep going, guys. And if the computer reboots and shuts down, then hang in there, right? I will try and log back on and restart the lecture. So let's just play that by ear. Gotta love Zoom.
You can and the update happens on your computer. Like you can set it for like the end of the day or something like that.
Yeah, it's just I know I think you probably can do that. Janera, I wrote my master's thesis on a typewriter. And typewriters don't, yeah, you know, so I'm a bit tech nerdy, but I mean, tech challenged, but thanks. I'll see if I can figure it out. If it does update, hang in there and I'll see if we can come back. So let's keep going. So ozone. So this is a very important diagram, everybody. And it's important because it makes this critical distinction that there are 2 different types of ozone, right? There's ozone in the troposphere, the lowest levels of the atmosphere, and there's ozone in the stratosphere, right? Chemically, they're identical. They are both made up of 3 oxygen atoms, okay? They perform very different functions and they form differently. So for now, let me just make this point and we'll leave it there, that the ozone up here in the stratosphere is what we will deal with in chapter 5. That is the protective ozone layer, right? In chapter 4, we're dealing with this low-level ozone here. And the difference here, everyone, is that this low-level ozone, as I made the point early on, is a human-made pollutant, right? You release nitrogen oxides or volatile organics, and that gets converted into ozone. So low-level ozone, I cannot stress this enough, is a human-made pollutant. It gets into your airways. It's also part of this orangey stuff that we call photochemical smog, right? Stratospheric ozone forms naturally, protects us from ultraviolet radiation. Tropospheric ozone is a pollutant and is human-made. I hope that makes sense to everybody. That's the key distinction right off the bat. One way to think about ozone is this little phrase, good up high, bad nearby, right? It's good up high because it protects us. It's bad nearby because it's a pollutant. So how does it form? I alluded to that. So for example, I've already illustrated this, but let me just go over this. Nitrogen dioxide, right? Emitted from a variety of sources that you see here on the right. Or these things, volatile organic compounds, and that's exactly what they are, a range of compounds that are problematic. Those primary pollutants get into the atmosphere. Sunlight then breaks them down, releasing the oxygen, forms with O2 to form low-level tropospheric ozone. Does that make sense to everybody? Human-made pollutant. You have to emit these first and then have sunlight interact with it to then produce low-level O3, right? Which is why it's a human-made pollutant. So here, for example, is Houston. I know there are some of you in Houston. Go down there frequently. My wife is from Houston. And this shows ozone 8-hour averages. Now, the scale here is not the actual scale on the EPA primary standards. This has been linked to a color. And I'm going to talk about that in a second, right? The air quality index, okay? When you put up on a billboard, when you're driving down I-30 on a bad day, it wouldn't make much sense to the public if you said, okay, hang on, folks. The ozone levels today are 0.07174 parts per million. Everybody run indoors, okay? That's kind of like, well, that's a bit nerdy and scientific. So the air quality index is a nice, simple way of converting a standard into a color that people can understand, a score that people can understand. So anything that is, you know, approaching the standard goes up to that level yellow or 100. Anything that exceeds the standard then starts getting into the reds and the purples, right? So when you see on the billboards, this is an ozone level red day, okay? That means that the ozone levels are exceeding the national ambient air quality standards, right? So here's Houston. Houston has 12 counties that fail ozone, and anything in yellow and red is problematic. Why do you think Houston is so problematic in terms of ozone? What's going on in Houston? Someone from Houston?
Well, like, I'm not from Houston, but there's a port there, so I assume there's a lot of industry.
Your assumption is correct, Holly. Yeah, and what kind of industry?
Would gas and, I'm from Houston, so would it maybe be gas and oil?
It may well be, right? Okay, so here is Trinity Bay, Pasadena. Some of the world's most sophisticated oil and petrochemical refineries are here, right? I think Pasadena's right there, okay? Why is that important? Because you're emitting those primary pollutants that then can get transformed into ozone very quickly, okay? I don't know if anybody's experienced the beauty of Houston traffic and Houston drivers. Yeah, right? Very busy, lots of highways, lots of cars, and it's hot and humid, right? So you've got sunlight here for long periods of the year, and you've got all the sources, okay? Makes Houston problematic. Certainly not unique or alone, but just problematic in terms of tropospheric ozone, okay? Get our friends in California. Let's go back to the geography for a minute here. Why is California so problematic? Well, let me just address this question from Keegan. Did the pandemic help to, I've lost the chat portal here. Here we go. Did the pandemic help to decrease air pollution in areas overall? Yeah, it did. We're still waiting to see what those numbers look like. It's an interesting question. But the pandemic has improved air quality in many cities of the world, and it's also reduced our carbon footprint quite dramatically. Now, again, I'm not advocating for a pandemic to help our environmental issues, but it did. It's going to be interesting to see what those final numbers look like. So here's the situation in California. California, the bottom one is a photograph I took from Griffiths Observatory. You can probably just make out the Hollywood sign there on the right, right? And California, along with many other areas in the world, Beijing is another example, New Delhi is another example. They sit in low-lying areas surrounded by mountains, right? So California sits in the LA basin, and these cities in the Central Valley here are sitting in a valley surrounded by mountains. Why is that important, right? Well, that's important because a unique meteorologic phenomenon develops in these low-lying areas like the LA basin and the Central Valley. And that phenomenon is called an inversion, okay? An inversion. What's an inversion? An inversion is when temperature increases with height. Now you may think, well, how does that happen? That's really odd. If I had a weather balloon at the surface and I let that weather balloon go up, doesn't temperature decrease with height? Yes, it does, right? You get into an aircraft and it may be 80 degrees Fahrenheit at the surface, and by the time you get to 35,000 feet, it's minus 50. So temperature decreases with height, but in certain circumstances, temperature increases. And how this happens in a valley or a basin is at night, when the ground cools, what happens to all that cool air? It sinks into the bottom of the valley, or it sinks into the bottom of the basin. And that develops a relatively warm layer above that cold air. And that's the inversion. And any pollution that is put out beneath that layer of warm air cannot escape, right? So in the photograph on the bottom here, there's an inversion sitting here above this smog layer, and it cannot escape. The only way it can escape is for some sort of wind or storm system to come through and blow it out of the basin or blow it offshore, right? Does that make sense? So when you're sitting in Miami and you're putting pollution out, that gets blown out into the Atlantic very quickly. In a place like LA, it gets trapped here and confines the pollution in places like the Central Valley. I hope that makes sense to everybody. Does that make sense? So the yeah, let me go back. Question?
You're saying that the ozone or the other chemicals are trapped underneath the warm air, and that's why we have this inversion, because it's just trapped.
Correct. No, it's a physical trap. It's like putting a lid on a pot, Mara. It's a physical trap, right? Because that pollution coming out of the smokestacks is hot. It begins to cool as it rises, and as it cools, it comes up against this warm air and it cannot keep rising. It literally acts as a lid on the environment. Okay. The air quality index, again, there's no details that I want you to remember here other than all they simply do. So let's just look at ozone here for a second. All they simply do. So here's the 8-hour ozone, right? And this is it's changed. So this is the 0.07 parts per million. So anything below that is moderate to good. Anything where that is exceeded is bad. So anything above 100 is poor, 200 is really bad, pretty catastrophic air quality, right? That's what the air quality index does. So the really good news, everybody, in all of this is this diagram here, right? This is the environmental success story if we just set ozone aside for a minute. When you look at how these indices have changed over time from 1970, like in the US, GDP is up, the number of vehicle miles is up, population has increased, energy consumption is increased, carbon dioxide emissions have increased, all of those have gone up. Whereas the aggregate emissions from those 6 common pollutants, if we take all of those trends, air quality's improved, with the exception of ozone, right? And that's as a result of technology, catalytic converters, scrubbers going into smokestacks in chemical factories, and legislation like the Clean Air Act, right? That went into effect in 1973 and has been strengthened and revised. Does that make sense, right? I really want to emphasize that air quality here is, it's not all rosy, it's problematic, but we've made tremendous inroads. Just to address Keegan's question, did the pandemic help to decrease the air pollution in areas overall? This shows March 25 through 2019 for nitrogen dioxide on average. This shows March of 2020, just as we started going into lockdown, right? And this next one here shows the Central Valley. I thought I'd just include this. This is pre-shutdown. Here's LA. This is all pollutant concentrations, aerosols. So here's LA pre-shutdown, Central Valley. Here's the full shutdown, right? In the Central Valley, you can see how air quality in LA dramatically improves, right? As a result of that. That's all nitrogen dioxide concentration. I don't know if that addressed your question, Keegan. Okay. Well, it's 11:36 and my computer is still chugging along. So if you can still hear me, let's keep going. Let me address air quality internationally, globally, right? So things are good in the US. Yes, we've got ozone issues. Yes, a third of the population lives in compromised air. But globally, the picture is really, really poor.
I think his computer reset. I don't know.
Yeah, I think so.
He spoke with the devil and it happened.
So do we just wait in here?
Yeah, I think he said to wait. Maybe, I don't know. But yeah, I think he said he did.
He said to wait.
Safi?
Darn you, Mr. Gates. Thank you for hanging in there. All right, one sec. We are back. Okay. All right, yep. Now it's probably going to want to install all sorts of things and no, go away. Close that down. All right, let me get back to where we were. Close that down. All right, we're almost there. We're almost there. Screen, there we go. Let's do that. I think we're back. All good. Keegan, I see you on my screen. We're back. Attaboy. Thanks, everyone. Okay. Some things are just outside of our control. Okay. Let's talk about air quality globally here. Here's where things get really interesting. So we're looking here at PM 2.5, right? Again, that's very, very fine particles. Cannot be seen with the naked eye. Burning of wood, biomass, smoke, soot, anything like that goes into the atmosphere. Burning of agricultural crops and so on, okay? And here, we're looking at the standards set by the World Health Organization. So let me just refer you to the scale here. So anything, so the actual scale here is particulate matter in micrograms per cubic meter. All you need to worry about is anything in green or blue is good, right? Anything in green or blue, air quality is totally acceptable according to the World Health Organization guideline. Remember, the US here, we've just said O3 is problematic. This is looking at suspended particles, right? So what do you notice here when you look at the world's picture? The gray countries just don't have data. For example, Africa, you know, parts of Southeast Asia and so on. But what's the take home? What's the big take home that you see here in terms of air quality? Anything in yellow and above is compromised.
To me, it looks like that more developed countries have better air quality. I don't know
Okay.
about like Russia, I don't know. But like underdeveloped countries have bad air quality, or developing countries.
Okay, fair point, right? We've got some ones here in Europe. Let me just circle those out there. Are okay, aren't great. Former Eastern Bloc countries, quite interestingly, I think, jump out there. But Holly, your point is well taken. And in particular, right, we look here. for massively compromised air quality. Okay, South Asia, including India, Pakistan, Bangladesh, Southeast Asia, right down here, Indonesia, Malaysia, and East Asia in particular, China and Mongolia, right? I think what's quite interesting is when you look at the world's most polluted cities, not capital cities, but for just cities. So these are cities that at the end of 2019 were the top 10, okay, in terms of particulate matter. And what I've done here on this plot is I've also put in US cities for reference. The most polluted city, not for ozone, this is just particulate matter, is Portola, California at 17 micrograms, right? LA is 12.5. Dallas is 12.3. We do have particulate matter in and around here, but look at the 10 most polluted cities in the world. Okay? US cities don't even come close. And not only that, is that 9 of the 10 are either in India and Pakistan. Now, I don't know what your preconceived ideas of or notions of air quality were coming in here, everybody, but I think a lot of people just assume that China has the worst air quality in the world, right? We've heard of China, all their air issues, but in fact, they have done a remarkably good job, relatively speaking, because they're installing so many more renewable technologies moving forward, that it's South Asia, India, Pakistan, Bangladesh, and so on that are having the most compromised air quality. Let me just share a little personal anecdote here with you to give you a sense of scale. So in when was this? November 2017, I went to a meeting in New Delhi. I don't know if any of you have been to India. This is the most extraordinary, beautiful, vibrant country I think I've ever been to. The capital, New Delhi, has something like 23 million people in it. That's the same population as Australia, right? So you talk about concentration of people. And I landed on a Sunday evening. This was the newspaper on the Monday morning in my hotel room in November. Delhi gasps for breath. Air quality severe. The government told to prepare for odd even. Odd even means on odd days, if your license plate is an odd number, ends in an odd number, you can come in on a Monday. If your license plate is an even number, you can come in on a Tuesday. This is a photograph of one of the beautiful buildings in Delhi in the morning. That's not fog, that's pollution. Okay, this was Monday morning. You know, now masks seem like second nature. Okay, everyone was wearing masks. They ran out of masks. By Tuesday in my hotel, and this is no exaggeration, I could barely see the breakfast buffet. I mean, literally, the particulate matter had infiltrated into the lobby of the hotel that we were kind of fighting through the fog to get to the pancakes and the waffles. It was just the most remarkable thing. And here's what I'm talking about, right? Take a look at this. So this is the air quality very near my hotel, which was down, let me just draw a circle here. Okay. My hotel was just down here. The purple's not showing up real well. Let me use the red. So my hotel was just down here, right? This over here shows the pollutants by hour. And you can see ozone here is not an issue, right? Ozone is green, green, green. There's a little yellow blob, but ozone is fine. It's all particulate matter, okay? And particulate matter, these numbers are the air quality index. Remember I said anything above 100 is bad, 200 is catastrophic. 999 means it was off the scale. They could not measure the concentration of particulate matter. It was so high. It was unbelievable. It was extraordinary. And it's an issue that happens in October and November and December pretty much every year. So what's going on here? Well, Delhi is very populated, right? And there's lots of cars, but it wasn't really that. Here's the issue. This is the fascinating thing about air quality in a place like New Delhi. So here's New Delhi over here, and it sits in a basin. Here is the front range of the Himalaya mountains, okay? And all of these red dots are fires, not wildfires like California wildfires. These are large-scale fires where farmers traditionally at the end of the harvest season burn their crops, right? It's called stubble burning. And it happens in many countries around the world. It happens in Africa. And in fact, they even do it in the United Kingdom. You burn the stubble to try and get those nutrients back into the soil. All of this, what looks like cloud, is all pollution. So what happens is in September and October, the farmers harvest their crops. They burn their crops. So you've got these massive fires. And then the cold air, just like I talked about California, the cold air sinks down the Himalayas and pushes all of that polluted air into New Delhi. Agra, on the Wednesday, we went to go and see the Taj Mahal in Agra, and the air quality had improved at that point. But driving on a highway at 70 miles an hour in a bus with visibility at 10 feet was just a little scary, right? So when it comes to air quality, things have certainly improved in the US, and there's reasons for that. We'll explore that. But globally, we face significant air quality issues. And China, incidentally, realizes unequivocally that compromised air quality it's a catastrophe for the economies, right? Not only health and human services, but for the economy at large. So let me stop there and see if there are any questions from all of you on air quality and pollution. And thank you for being patient and hanging in there whilst Mr. Gates rebooted my computer. Any questions, thoughts, comments? All good. Okay, so what we're going to do next is I'm going to look at the schedule. I know there's acid rain, and I'm going to just bench acid rain for a minute because I want to get to stratospheric ozone. Let me give you a heads up as I've got 2 minutes here, everybody. This chapter on ozone, chapter 5, I think is the most complicated of the lot, right? And I haven't made it complicated just to be mean or spiteful. But we're going to get into the atmospheric chemistry of ozone a little bit here, stratospheric ozone. It's a really interesting story, I think, as to how we discovered it and what we're doing to what it looks like heal the ozone layer. So it's another environmental success story, but it's going to be a pretty solid challenge. So yeah, that's it for today. Welcome back. And as always, I will hang around and see if you have any questions.
Thank you.
You bet.
Thank you.